operations on nth roots, let's check out this subtraction of radicals. Now, when we're adding or subtracting radicals, we have to be very careful, okay? We need to have like terms. And like terms, when we're talking about radicals, means that we have to have the same radicand in the radicals in order for me to be able to combine them and add their coefficients. So right now as it stands, I cannot add or subtract these two radicals. They do not have the same radicand. I'm going to try and simplify these two radicals separately, and maybe I'll end up with the same radicand. Let's see what we get. If I take the square root of 12, now remember, to simplify this, I make a list of all the factors of 12. I always start with 1, even though 1 times 12 are never going to be candidates for simplifying 12, because that just gets me to 12 again. I've done nothing. But I always like to start at 1 so that you know that you can go in order and you don't miss any factors. The next pair of factors is 2 times 6. The next one is 3 times 4. And the next one is 4 times 3. But 3 times 4 is the same as 4 times 3. I stop. That tells me whenever I reach a repeated pair, that means I've reached the end of the factor list for that number. The other number is 75. Let's make a list. I have 1 times 75, 2 times nothing. How do I know times nothing? Because 75 is an odd number, and I know it's divisible by 2 if it's an even number. So I know this is not divisible by 2. 2 times nothing, 3 times 25. If you think about 3 quarters, right? Having 3 quarters gives you 75 cents. So 3 times 25, 4 times nothing, 5 times something because it ends in a 5. So this must be divisible by 5. 5 times 15. 6 times nothing, 7 times nothing, 8 times nothing, 9 times nothing, 10 times nothing, 11, 12, 13, 14, 15. Okay? 13. Wait, 13. I can multiply 13 by 5. But that would give me 65, not 75. Okay, so then I get 15 times 5. You're done with your list. And now I have to choose which of these pairs am I going to use to rewrite 12 and which of these pairs I'm going to use to rewrite 75. And how do I do that? Well, I'm going to rewrite 12 as the pair of factors in which one of the factors is a perfect square, and that's 4 times 3, minus, and I'm going to rewrite 75 as a pair of factors in which one of the factors is a perfect square, 25 times 3. There you have it. You have 12 minus the square root of 75. Square root of 12 minus the square root of 75. I've just rewritten them. And now I can separate these, since they're in multiplication, I can separate these into their separate little radicals like that. And the square root of 4 is 2. Square root of 3. I keep square root of 3. I can't simplify it any further. Minus 5. Square root of 3. 5 is the square root of 25. 2 is the square root of 4. And now notice I have coefficients of 2 and 5, and I have a radical with the same radicand. They both have a radicand of 3. That tells me that these are like terms. And if they are like terms, I can add or subtract them. So this is like having an x. It's like having 2x minus 5x, where x is the square root of 3. And 2x minus 5x is negative 3x. If I do the same thing here, 2 square roots of 3 minus 5 square roots of 3 will give you negative 3 square roots of 3. So when we add or subtract, we add or subtract the coefficients. We do not touch the radicand. We do not do anything. We just keep it. Okay? When we multiply radicals, like in the previous video, we can multiply the radicands together, but not when we're adding or subtracting. Okay? I hope this refreshes your memory on how to subtract or add radicals. The important thing here is that when you simplify, you can combine like terms only if the radicands are the same. Okay, I'll see you in the next video. We're going to multiply binomials with radicals. See you then.